Should I do that, or you're okay with that?
Yeah, if you could go over the formulas.
Okay, so when we multiply, this is m, and this is n. So when we multiply two exponential notations with the same base, we copy the base and we add m plus n. When we raise to a power m raised to n, we multiply m multiplied by n. When we divide a to the mth over a to the nth, I copy the base and subtract, always in this order. From the exponent of the numerator, I subtract the exponent of the denominator. If I have a base raised to a negative exponent, this is a fraction, which is 1 over a to the nth power. Something very important to refresh our memory on, any number raised to 0, I'm going to write here underneath a not equal 0. So I'm not talking about 0 raised to 0. This is not 1. But this is always 1 as long as the base is not 0. So all these rules apply if the exponents are negative, same rules. If the exponents are rational, same rules. Everything the same. One other refresher that before we look at some problems, the radical notation. Radical notation. So the general radical notation is this: n, the index, a, mth, the power. This is a radical notation, but it can be changed into an exponential notation. A is the base, m is the numerator of the fraction, and n is the denominator. So this is what we talk when we talk about rational exponents. This is what we mean. So if I have, for example, this cube root of 5 squared, this is 5 raised to 2 over 3. If, let's say, I'm given x to negative 1/3, I'm using a negative power, which is 1 over x to 1/3. But now I also know that 1/3 is the same thing with 1 over the cube root of x. And yes, normally we should rationalize that. Maybe there is one other thing that I'd like to add here. I don't remember if I did this with you already. The square root of x squared. You could say, yeah, that's easy. It's 2 over 2. You just showed us. If this is 2 and this is 2, this is a. The answer is not so fast. Because remember, this quantity has to always be positive as the answer, right here, positive. So then it has to be the absolute value of x. And the absolute value of x, the formal definition, is x when x is positive, so I don't really need the absolute value bars, but it can be replaced by negative x if x is less than 0. So this is another very important concept. And I think we can now play a little bit with any of these examples if you or problems if you want to choose. They are again on page 64 if you'd like, from 55 through 64, and also from 65 through 74. If not, I will choose. Okay, I'm going to choose 60. You can choose the next if you want. On 64, and we have y raised to negative 2/3. They say write it as a radical. Fine. This must be 1 over y to 2/3 by the negative power rule, this one. And then I can change it back into a radical as the cube root. The denominator is always the index, and the power, the numerator is always the power. Now, let me know if you want to choose. So I'm choosing 70, which is 1 over, no, something, that's 72, sorry. So the cube root of t to the 6th. So the cube root of t to the 6th, they want us to write it as exponents, using exponential notation. So all I have to do is write t raised to which power? Can anyone tell us which power? So this is the same with t raised to, what do you think?
Is it t squared?
Yes, of course, 6 divided by 3. Okay, so let's also look at a domain if you'd like to choose. 79 through 86. Let me know if this is enough. If you want more, we can do more. Maybe when you work on the problems on Thursday, you'll find something that we didn't cover, so we can do it together. Yeah, maybe 74 is a good one, because we have the square root of x cubed plus 4. And they want us, and this is important, they want us to change it into a rational exponent. How do I write this with rational exponents? This is important because you'll see in the next chapter why. Anyone? Anyone? Well, this is the same thing with x to the third plus 4 raised to 1/2. The denominator is the index, and the power, the numerator is the power. Before I look at a couple of domains, we did all of these in different problems, but let's do another domain. I want to ask you the following. Let's say I have this function I would like us to decompose this function only in 2 functions. We can decompose it in more than 2, but let's say we decompose it in 2 functions. I would like an inner and outer. I'm getting at g comp h of x. So the inner is h, the outer is g. So I like us to decompose this function into an inner and an outer. The inner meaning which portion of this function, if I want to evaluate it for 1, which portion of this function I will perform first, which operation, that will be the inner, and what follows after that, when I get a number, then I apply the outer. So, can anyone decompose this function into an inner, or at least tell us which function will you evaluate first? And that will be our h of x. Inner is h of x.
Would the inner be the square root of x plus 3?
You can consider that. I would have said x plus 3 first, but that's fine. Yes. You want to consider that you will evaluate this and you will automatically apply the square root. That's fine. Now we want to determine an outer, which in this case is g of x. So now I have a number. This is a number. Which function I apply to this number?
Say 1 over the number?
Yes, that is correct. 1 over the number. Exactly. That's what it is. Thank you. Well done. We need this for the chain rule. Extremely important to be able to decompose the function. Yes, you can say, but these are 3 functions. I would have to agree. This is function 1, this is function 2, and this is function 3. But I only needed a warm-up just to decompose it into 2 functions. That's okay. Any preference for domains here? Oops, I touched that wire again. So any particular, which one?
We already do 82.
That's fine, 82 it is.
Oh, no, I didn't know if you did already. It's all the same.
No, I don't think we did 82. Let's do 82. X to the 4th plus 7 divided by x squared plus 6x plus 5. Okay, so I can state the domain of this function. The numerator can be anything. The numerator can be anything, 0, infinity, whatever. I don't care. But the denominator, x squared plus 6x plus 5, cannot be 0. So obviously I need to factor, or if it doesn't factor, I will have to use the quadratic formula. So how do I factor this?
Maybe x plus 3, x plus 2.
I cannot multiply 3 by 2 and get 5. You're on the right track though.
That's what's
That's okay.
going to be.
X plus 5, x plus 1.
Very good. So obviously x cannot be negative 5 and x cannot be negative 1. So now I'm not interested. This is required. If I don't determine this, I don't know how to write the domain. So can anyone give us the domain? Knowing that x cannot be negative 5 and x cannot be negative 1. We had like 2 or 3 domains like this today. Anyone?
Would it be negative infinity, comma 5, and the unit of 1, comma...
I have to start where I stopped.
My bad.
No problem. That's why we discuss all this. So I don't have enough room here, so I'm going to continue here. So union, negative 1 to infinity. So if I omit this, I omit infinitely many values, x values. Between negative 5 and negative 1, there are infinitely many. So we have to mimic exactly what we wrote here. We wrote not negative 5 and negative 1, but everything else goes. Good. Anything, any questions? Do you need other examples? Do you need anything? Okay, so final step from the review is to pick any problem from demand and supply to find the equilibrium point. So let's talk about demand and supply for a minute. They could be different graphs, not just linear functions. It could be any, as you see, some of them are linear, some of them are not. But the idea is that, so this here is price, X. And here is, well, quantity, but the same thing with the demand of price X or supply of price X, which basically means quantity. So demand, D of X, assuming that the price is denoted by X. If it's denoted by P, then it's D of P, and S of X. So obviously the demand as the price increases, for example, let's say we're looking at the housing. As the price increases higher and higher in the millions, less and less people can afford. So this is a potential demand function. Because as the price increases, the demand for a product will always decrease. Fewer and fewer people can afford it. But what happens with the supply? Of course, the manufacturing units want to sell their products at as high price as possible. So normally this is the situation for the supply. So they are willing to supply at higher and higher prices, more and more quantity at higher and higher prices. They are willing to, but the demand is not there. Well, where the demand and the supply intersect, this is where we have the equilibrium point. Where the demand at this point, the demand of X equals, for a particular price, equals the supply for that price. Those two equations are equal. So, oh, I touched that again. Okay. So, EP is the equilibrium point where the demand and supply are the same. So now please choose anything, it doesn't matter, any problem in which we are asked to determine the equilibrium point. And of course the equilibrium point will be given by X, which is the price, comma, either D of X or supply of X. It doesn't matter because they are the same at that point. So this Y value is identical. So this point here, this value here is D of X equals S of X for this particular price, X. Okay, any preference? Or I will choose
94.
94. 94, right here. So we have the demand, so that's 94, and this is page 65, and the demand, they call it Q. I want to differentiate between the two. It's Q and Q, but they just write demand and supply. It's up to you. Use the notation you like. I accept any notation, but I prefer to explain D of X, which is 7 minus X, and the supply S of X, which is 2, the square root of X plus 1. And the graphs are here. We don't have to graph them. They're here. And it says the price, so we have to look at the measurement unit, is in thousands of dollars. So we have to keep that in mind. And the quantity in thousands. Thousands of dollars and thousands. Okay, perfect. So we're asked to find the equilibrium point. Find the equilibrium point. Good. I have to set them equal to each other. 7 minus X equals 2, the square root of X plus 1. It's a perfect pick because this is a radical equation. Does anyone remember what we need to do when we solve a radical equation?